Imagine dropping a glass of water onto the floor. It shatters, spilling water across the tiles. You have seen this happen hundreds of times, and you can easily picture the event in your mind. But you have never, not even once, seen a shattered glass spontaneously assemble itself, collect the spilled water, and leak back up into your hand. We find this completely ordinary because we live in a world where time has a strict one-way direction. We can remember the past, but the future is a complete blank. Yet, if you look at the fundamental equations that govern our universe, from Isaac Newton's laws of motion to quantum mechanics, almost none of them care about the direction of time. The math works exactly the same whether time runs forward or backward. So why is our consciousness locked into a one-way street? Why can we remember the past, but we can never see the future?
To understand why we are blind to the future, we have to start with a shocking truth about physics. At the most fundamental level, time symmetry reigns supreme. If you were to watch a video of two billiard balls colliding, and then watch that same video played in reverse, you wouldn't be able to tell which version was the correct one. Both the forward and backward paths perfectly obey the laws of gravity and momentum. The fundamental equations discovered by Newton, James Clerk Maxwell, Albert Einstein, and Erwin Schrödinger are all time reversible. They make no distinction between the past and the future. According to these laws, there is no mathematical reason why a shattered glass cannot reconstruct itself. The particles would simply have to reverse their velocities and collide in just the right way to lift the glass back up. Yet, in our daily lives, this never happens. The universe clearly has a preferred direction. Physicists call this the arrow of time. The reason time flows forward for us comes down to a single powerful concept in physics: entropy. In the late 19th century, physicist Ludwig Boltzmann helped formulate the second law of thermodynamics. This law states that in any closed system, the level of disorder or entropy must always increase over time. Consider a clean room. There is only one specific way for the room to be perfectly organized, but there are millions of ways for it to be messy. If you don't actively spend energy to keep it clean, the room naturally becomes disorganized over time simply because disordered states are vastly more probable than ordered ones. The same rule applies to the universe. At the moment of the Big Bang, the universe was in a state of extremely low entropy. It was highly ordered and compact. Ever since that moment, energy has been dispersing, spreading out, and becoming more disordered. When you drop a glass, you're converting a highly ordered state, a solid structured glass, into a highly disordered state, scattered pieces and heat generated by the impact. The thermodynamic arrow of time is defined by this relentless slide from order to chaos. But how does the spreading of energy in the universe dictate what happens inside our minds? Why does our psychological arrow of time, our ability to remember, align so perfectly with this thermodynamic arrow? Our brains are essentially highly advanced biological computers. To record a memory, our brain must change its physical state. It has to create new connections between neurons, constructing a highly ordered file of information that mirrors an event in the outside world. According to the laws of thermodynamics, creating order inside your brain requires energy. Your brain must burn calories, food, to power those neural pathways. When your brain consumes this energy to write a memory, it inevitably generates a byproduct, heat. This heat is expelled from your head into the surrounding environment. While you have created a small pocket of order inside your brain, the memory, you have generated heat and increased the overall disorder or entropy of the universe around you. This means that the physical act of remembering is, by its very nature, an entropy-increasing process. Because our brains are physical objects bound by thermodynamics, we can only record memories in the direction of increasing entropy. We can only remember the direction in which the universe is becoming more disordered, and we call that direction the past. If we tried to remember the future, our brains would have to absorb heat from the environment and decrease the universe's total entropy, violating the most fundamental law of physics.
While thermodynamics explains our biological limitations, Albert Einstein's theory of relativity introduces an even stranger perspective on why we don't see the future: the block universe. In Einstein's physics, space and time are not separate. Instead, they're woven together into a four-dimensional fabric called space-time. In this view, time is a physical dimension just like space. Just as Paris, New York, and Tokyo all exist simultaneously in space, the past, the present, and the future all exist simultaneously in space-time. The year 1920, the year 2026, and the year 2120 are all equally real, carved permanently into the fabric of the cosmos. Einstein famously wrote, "The distinction between past, present, and future is only a stubbornly persistent illusion." If the future already exists as a fixed coordinate in spacetime, why does our consciousness experience it as a continuous forward sliding journey? Why can't we simply look ahead the same way we can look down a physical road? The answer may lie in how our conscious minds are structured. We are biological entities that rely on chemical reactions, which require a flow of energy. Because we must consume energy to think, our consciousness is physically bound to slide along the thermodynamic gradient. We are like passengers on a train moving along a track of increasing entropy, unable to turn our heads to look at the stations ahead.
Quantum mechanics introduces one final layer to this mystery. At the quantum scale, the future is fundamentally different from the past. Before a quantum particle is observed, it exists in a state of superposition, a wave of multiple, overlapping probabilities. The future is not a single locked-in reality, it is a spectrum of possibilities. However, when a measurement or interaction occurs, this wave function collapses. The multiple probabilities condense into a single concrete outcome. This transition from a wave of probabilities to a single definite history is a one-way process. We cannot see the future because in a very real, physical sense, the future does not exist yet as a single resolved reality. It is a cloud of potential. Only when the present moment rolls forward does the universe actively choose which probability becomes part of the permanent, unchangeable past. Ultimately, we do not see the future because the very structure of our biology, the rules of information processing, and the expansion of our universe are all bound to the relentless rise of entropy. We are creatures made of the same stardust and bound by the same thermodynamics as the rest of the cosmos. We cannot remember the future because the physical machinery of memory requires us to burn energy, creating the very past we look back on. We are passengers on a one-way journey through space-time, sliding forward through the stubbornly persistent illusion of time, forever turning the infinite probabilities of the future into the permanent history of the past.